So hi, everybody. Thank you all for coming to my talk on basically bad jokes, internet memes, and dated humor. Who in this room is an Android developer? Cool, most of you. Who in this room uses dependency injection for their projects? Cool. Who knows what dependency injection is? So I'm going to cover a few topics and just kind of try and get through as lot of content as quickly as I can, so you're going to have to bear with me, I guess. So what is dependency injection? And sort of how do we utilize this in our projects? So let's take a simple sample. This is the same sample is actually provided via the Google documentation. And we have a simple car. Now, the car has a dependency, which is the engine. Because the car cannot operate without an engine, it has that required. But in this case, you know, it's being instantiated in the class itself. So it's really difficult to actually manipulate this if you want to perhaps change it into a fake for testing purposes or reuse the implementation for something else. So how would you change this to then allow for that to happen? So quite simply, you just change it so it's adding in the constructor. In the constructor, you can then provide it with a different type of engine in the different scenario. And then you're requiring the caller, when they're creating the object in the first place, to provide you with that engine. So relatively straightforward topic. But a lot of people have been saying recently, well, you know, Dagger's just a bit too much. It's too confusing. There's too many things to kind of keep track upon. And it doesn't really work well with Android. I'm just going to use something else that maybe works better with Kotlin, various other dependency injection frameworks that you might already be aware of. So that kind of sparked a lot of heated debate on the internet about the benefits of which dependency framework and why should I use Dagger over something like Coin, for example. And one of these conversations was found on Reddit, asking which one of these is best for dependency injection. And lo and behold, the first comment from the head of sales at Bob's Discount Action Bars. Yeah, triggered. This actually, he had a lot of heated discussion and a lot of arguments, and it was interesting because Coin is not a dependency injection framework, it's a service locator. And it uses some clever reify techniques to actually provide this. An example of the service locator would be, as you can see here, where you have an object that contains your dependencies, and then the dependencies are retrieved from that in your class. The difference here is your class is actually asking for these dependencies instead of being told what they are. And this is sort of an example of the tell versus ask kind of scenario. So this is fine for smaller projects, but it doesn't scale well. And as we saw from the Android Developer Summit, Google heavily recommends us to use Dagger. So what is Dagger? So Dagger is a dependency injection framework for Android and Java, or more for Java. And it has compile time safety through Cogeneration. Dependency injection implementation. Generates the code for injection. And it's compile time safe, so it does not use reflection. So the important thing to remember about this as well is that it's written in Java, for Java, by Java, with Java developers in Java. I get the point. So what's cogeneration then? Kind of taking a step back. It's important to understand what cogeneration is and how it's utilized in our projects. And it's based upon annotation processes where you would annotate something and then you'll have a code processor run upon this and generate code afterwards. It's not possible to modify existing code, but you can generate new classes and new implementations. There's a lot of examples of these already around, things like AutoValue, Lombok, which actually does some clever byte weaving thing to actually modify your code, and it's damn voodoo. Stay the hell away from it. But then, Dagger is another good example. So let's get back onto Dagger before I leave you off on a tangent. There's a great talk from Jake on how to use Dagger with starting projects. And his point is that if you start using Dagger when you start off with a project, you won't have to worry about implementing it later on when you have the scalability issues that will come with using something like a service locator, for example. So a bit of history on Dagger. It's not exactly the new kid on the block. It's been around for a little while, and it's gone through a few iterations. So there was the first sort of juice type thing. Not strictly Dagger, but it was a lot of the injection paradigms and the first implementations of the JSR 3.3.0. And then we had the first iteration of Dagger. This is from the Square people. It was sort of based heavily on Juice, but was more lightweight and available more for Android. But it uses reflection quite heavily, so it's not super great in that scenario. And then we have Dagger 2. So this is Google then kind of taking back this project and saying, we're going to maintain this, we're going to build it. And they decided to kind of drop reflection because reflection's bad, okay? There's a great talk from Greg Kick on this about the improvements made on Dagger 2 versus Dagger 1. I recommend checking out. I'll share some links at the end of the slides. So, introduce Kotlin. So introduced in like 2011 as Project Kotlin, and then stable release in 2014. Then kind of garnered more kind of support in the Android community after Google supported it with the announcement the year before last, and that was amazing. So Dagger can work with Kotlin. It does, it is interoperable, but remember that it's written in Java and it's reading Java code. So you have to remember the code that Kotlin generates is eventually Java for JVM, and it's sort of working with that. So it might not work in the way that you think it might. But the Kotlin compatibility has already started underway. So one of the first things is Dagger Qualifiers. Now, this is if you've got multiple dependencies of the same type, and you want to be able to say which one should I use, because otherwise Dagger's not going to know, and it will just kind of fail at compile time, which is a good indication of how to use your dependencies. And it's also going to happen a lot if you kind of use primitive dependencies in your dependency graph. You can either create your own qualifiers, or you can use the existing named annotation with your own string name here for. And there's a retention here. So the retention annotation declares on how this annotation should be applied to your class and how it should be stored. So if it's going to be available in the binary, if it's going to be available at runtime, if it's only going to be available in your kind of IDE environment. And it needs to be at runtime so that Dagger can actually then detect when the compilation is happening, what indication you're giving to it. So if you have an annotation on your dependencies, make sure to use the runtime retention annotation. So it might look like this. You've got constructor injection, and you've got name parameters here in your constructor. So you're getting the same type, and you're saying that player 1 and player 2. So these are distinct, different dependencies, and they will exist as different dependencies in your application graph. You couldn't just inject player somewhere else without an annotation that will have that requirement. But it doesn't actually generate the way you think it would. So constructor injection actually ends up a little bit different. This is what the decompiled version of the Kotlin class might look like if you decompile it into Java. So how do those annotations affect the compiled code? So we've got the named annotation, the place that Dagger needs. Cool. So I'm going to have to stop myself here a little bit because I need to show you some more memes, and that's very important. It's an important part of the process. But there are some things that have sort of changed since I gave this talk the first time, or since I started preparing this talk. It's also led to an interesting conversation yesterday where we were talking about difficulties of publishing things when, by the time you finish developing something or building something or writing something, the content's changed or somebody has then done it before you. So I'm going to do this anyway, but some of this might be a little bit out of date. I will go over what is out of date and what has changed and what you have to know about these things. So we still give you talk even if it's out of date. The changes in particular are these kind of Kotlin and Dagger best practices. So this issue opened up on GitHub a little while ago about how people use Dagger with Kotlin and some of the pain points, some of the difficulties that people have, and how these can be alleviated and improved upon. There's a very active conversation going on here, and there's active work going on behind the scenes as well. So I'll be able to let you know where the content's changed as is relevant. So what about field property injections? We looked at constructor property injections, but what if we have a fields injection, like on a lot of Android components? Well, properties aren't the same in Kotlin as they are in Java. They're a little bit different. You have synthetic operators, synthetic accessors, sorry, and it's public by default. You can access internal things from Java. It's lots of different things going on here. So let's take the example here. We have the inject and named annotation on our dependency. Now, this should just work, right? It looks straightforward enough. But no, unfortunately, it won't, because the accessors for these properties are built as synthetic accessor properties from Kotlin. So then this annotation is actually applied to the accessor instead of the field itself. So then Dagger just sees as inject player and player. So you're injecting the same type, that's going to fail. So how do we resolve this? Well, we need to sort of tell Dagger where we want this annotation to live. So we need to specify on the annotation target. Now, there are lots of different targets available. You have things like fields, sets, gets, param, property, setparam, receiver, and delegates. Wow, that's quite tiring. Well, OK, so let's say we want this on the field. We want to use field injection, so we have the field named annotation on this. And this does actually generate the code we want. Hooray, we're winning. We have this inject properties, and it's working as it should be. But why should we use injection here, like in field injection, if it's so difficult? So let's compare it again to constructor injection. So you have constructor injection and property injection. The constructor injection, you have immutable properties, or you can use immutable properties. It's really easy to use. You just specify it in the constructor. That's what the dependencies I need. And it's reliable injection. So you can always rely on that class having everything it needs to do what it needs to do. If you're perhaps running under test, you don't want to be able to kind of do that manually or setting properties. You want to be able to actually be sure this class is going to do what I want it to do. Oh yeah, and compile time safety. So compare this again to property injection. We have mutable latent properties. Annotation targets are a bit unclear and hard to work with. Difficult to configure tests because you don't really know what's the configuration state and what properties it needs. It's not ideal. So, why do we use property injection if it's very clear that constructor injection is actually better for us? Well, that's because of our little green friend. Android. So with various Android framework types, such as the activity, the fragment, and the service, amongst others, you need to allow the framework to actually instantiate these. So you need to provide a no-arg constructor. So simply those constructor injection things aren't yet possible. Yet. You can sort of do this in later versions of Android. I'll go into that in a bit. So you have scope annotations as well. You might be familiar with these if you've ever used things like singleton or scope on your class. Looks a bit like this. You have the documented and retention annotation, pretty straightforward, and then you just apply this to whatever dependency you have. Like I said, if you've used singleton before, you probably are familiar with this, but it's really important to remember that singleton does not equal the singleton pattern. These are two different things. Though it is sort of often conflated and often confused, these are different things entirely. So for example, let's look at a Java class as a singleton implementation. We have this instance that creates itself, and then you retrieve the instance later on. You can't use any constructor parameters here, because how would you then access the instance every time if it's a lazy instantiated property? So the lifecycle is a bit difficult to manage, because this is then instantiated in the class path when the class is actually then first evaluated. So it's already there. You can't change it. You can't overwrite the property. If you want to work with a test instance, it's a bit difficult. So various complications in doing that. This is the same in Kotlin, where you have an object instead. It's much less boilerplate code, and we all love Kotlin. Hooray. You have other scopes as well, so things like activity scopes. Dagger treats any other custom scope a little bit differently than singleton, but generally you can assume that they live for the length of the component that you're building. And then you have to have this must be documented thing as well. So you apply your scope annotation to your context or your whatever you're providing in your module like so, and your instance will then live as long as your component that is built for that target. So what is activity scope? But Dagger does not care about that. You can name it whatever you like. This could be fragment scope, lifecycle scope, view model scope, DevFest scope. It really doesn't matter. Dagger just treats it as a scope annotation, and then that will apply. You can't use the same one on the same one on different components. You can't use different scopes on the same components. That will actually cause a compile time error, but that's more about Dagger documentation. You can also apply it to the actual property as well. So note how we've got the inject on the constructor here. We have to explicitly state the constructor is a separate entity, and we have the activity on the class. Now, the reason why I'm saying don't do this is because it's confusing the implementation with the usage of that. So the class should only really be concerned with its own implementation. You shouldn't really kind of conflate or kind of muddy up all of your implementation with how they're meant to be injected. Now, it's really easy and straightforward to use these annotations here, and it seems like it's a simple thing to do, but it's really not worth that scalability issue because you're going to find later on classes with these scope annotations, and you're going to find really weird race conditions where things are being persisted when you didn't think they were, and then you're share mutable state and all these different things. But generally, actually, there's another thing to bear in mind as well, is that there's another type of scope, and we have reusable. Now, reusable is really important because it has a different type of checking algorithm. When you have a scoped algorithm, so when you have a scope on a dependency, Dagger checks every time you retrieve that dependency to make sure that it's the same version, and then it's the same version on every thread. So it's synchronized, it's protected. Whereas reusable is simply an instruction to Dagger saying, reuse it if you can. So the different type of these behaviors are that of the double check operation, where you can see it has a synchronized block. Don't worry if you can't see this, it's very boring. Where it's using the double check algorithm to make sure it's in a synchronized block, and it's quite expensive to do this. So in the reusable, just use a single check, where it just says, do I have an instance that's available? So a bit more performant and a bit better to use. Always prefer reusable whenever you can. It's quite similar to the lazy in Kotlin as well. So in Kotlin lazy delegate, you have to provide a type of threading strategy. The default one will actually be synchronized, so this is actually the same as the double check algorithm. I recommend when you're working with Android and Kotlin lazy delegates to actually use the none thread safety model, because this is when you're already on the main thread. You generally don't have a lot to do with checking, and it's a bit more expensive, so things like having a lazy delegate to fetch a view model, that can easily be a lazy delegate. So I recommend using that. So like I said, if you have a reusable of the scope, it's great for expanded dependencies, works great in single-thread environments, not guaranteed the same instance on multiple threads, but you should really kind of try and keep your Dagger graph stateless. But use scope if you absolutely need to store a mutable state. Moving on, we have Dagger modules. So what's the current status quo? What's our current evaluation of what a Dagger module might look like? So we have this Java class. It's an abstract class because this means that Dagger doesn't have to instantiate it, and it can just inline everything it needs. You're instructing Dagger that it needs to bind context, and it needs to provide this sample repository. Now, the complicated thing here, or the complication here, sorry, is that we're using both a abstract and a static method in the same class. Now, this is fine in the Java world. We can do this, no problem, but not so much in Kotlin. So the first sort of few attempts were a bit naive. We had these companion objects, which would have your provide methods in them, and then you have your binds in your actual abstract class. Now, it gets the job done, but you have to annotate both the companion object and the module. And it's a bit kind of messy and a bit kind of tedious to set up as well. So having to change all your classes over. And a lot of times in the first few months, people just were leaving their modules as Java, which is actually not a bad idea. But let's continue on nonetheless. Let's try and find a solution to this. We can understand why it's bad, though, because look at the code generated from this. This is quite convoluted. You've got a singleton instance here, and then you've got the abstract methods defined, and then you've got your static methods defined, then you've got this companion object, which has got the same method twice. So you've got duplication. So it's not great. It's not ideal. It's not going to kill the performance of your app, but it's not the best case scenario. You may as well have just left it as Java. So the recommendation, if you're wanting to use Kotlin modules, is to do as so. We're using an object. Now, an object is a singleton, and then everything will be then static anyway. So you have this JVM static to instruct the compiler that this should appear as a static function. And in this context, you can then use these provides with JVM static. Still can't really use binds at the same time, though. So you can just rewrite your bind statements as provides, and it sort of gets around that problem a little bit. The generated code from this is a bit more straightforward. We don't have this companion object created, but we do still have this instance that's created, which is never, ever used. Because Dagger doesn't actually reference this, it just knows how to build it in your components, and it doesn't have to instantiate your class. Funny enough, I wanted to try this out as well. This is a little thought experiment, and I thought, well, if Kotlin is converting all of its top-level files into Java files anyway, what if I just named the file with the JVM annotation, and then have this kind of provides thing? Maybe this would work. It makes sense, right? And lo and behold, yes, it does. It generates the actual class that I want to have. but it doesn't exist as a Kotlin class, so it's unreferenceable from anything. It literally just exists on its own in a little island, and it can never, ever be used, which is tragic. But wait, there's hope. In Dagger version 2.25.2, we are now starting to see Kotlin support. This is incredible. We had the announcement at the Android Developer Summit, and this was met with a lot of support and a lot of kind of celebration. We were all drinking, it was great. So we started to see these things like the qualifier annotations. So these are no longer really an issue. So you don't have to apply this field annotation. And you can have things like I just mentioned, with the module, you no longer have to apply JVM static. So for the last, let's say 8 minutes, you can completely forget everything I said. It's out of date, gone. So qualifier annotations, they used to look like this. Now you can just drop that and use a simpler applied as we wanted to in the first place. Hooray! The modules, we have this JVM static, and we can just drop these. And now we have the module like we wanted to. Yay! And we're getting increased support here as well. So these are not just the only things being developed. These are continuous development going on more and more Kotlin support. So you can expect to see more and more things going on in the future. I recommend checking out the Android Developer Summit talk. I'll share the link at the end where they go into a bit more detail, but it's very worthwhile watching. So let's celebrate a little bit by learning about Kotlin Generics. Or not. Kotlin Generics are fun. It's an interesting way of understanding how it interacts with Java, because Java doesn't really support covariancy in the same way that Kotlin does. You know how these in and out types when you define a generic in Kotlin, and you don't really have that in Java. And it's sort of like voodoo covariance. Is it invariant? Is it outvariant? Is it covariant? Is it my variant? I don't know. And it's really tricky to kind of get your head around, and I'm still trying to manage that myself, actually. But it's important to know how it's operating with Java. So this complication of kind of interoperability with wildcards, because, well, Kotlin doesn't have wildcards. So it uses declaration site variants instead. How does this work? Well, let's take a look. So in Java, we've got this kind of collection that extends an iterable. And they have this add all with something extends E, this wildcard saying what this thing extends E. But why do we have this? I mean, couldn't we just simply have add collection? Well, funnily enough, the Java authors back in the days of dinosaurs decided this was actually an intentional decision to make sure that you couldn't do bad things like what I'm about to show you. So imagine you have a list of strings, and now logically you would think that list of strings extends a list of objects, right? A string is an object. You are wrong. That's not true. You can't add these things together. The reason is because of this. So let's say we have a list of strings using an array list, and then we cast it to a list of objects. And then we say, add a different type of object, and then we try and get the other thing. But wait, this is the wrong type now. There was a list of strings, not a list of ints. And now it's going to try and return the wrong type and have a runtime crash. So this is not ideal, and the original Java authors decided against this, so they introduced this wildcard strategy so that you have to add something that's extending that class instead. So that's sort of why we have that, and that's sort of a very broad, naive description of it. I recommend checking the documentation as well, where you'll find a lot more things to be confused about. So the easier way of thinking about it is if you're taking a value of something, then it takes the explicit type. If you're returning something back, then you use the wildcard. No, the other way around, sorry. If you're returning a value back, you then have the list of strings as the unextended parameter, and then you have the box parameter with the parameter. So if it's coming in or out, sort of like Kotlin in or out. Makes sense. So how does this work with Java and Dagger? So when you're using generic types in Dagger, it's generating all this code in Java, and it's reading your Java code, and it's reading the code generated by Kotlin for the JVM. So what looks right in Kotlin might not actually be the same thing that Dagger is seeing, and Dagger is seeing something a bit different. So you have to then kind of instruct Dagger to let Dagger know, it's like, hey, I know what I'm doing here, and this is basically having this kind of extension. So you have this kind of wildcard extension here. And this is particularly pertinent when we're using Dagger multi-binding. if we have several bindings and we want to have them into a set, and you want to inject them with the parameterization, this will fail, and we'll be sad, and we'll all cry. But how can we remedy this? We have this JVM suppress wildcard annotation. And now this is basically our way of saying, shut the fuck up, I know what I'm doing. So this hopefully will no longer be necessary, actually. So the team at the Android Developer Summit actually explained that they're hoping to get rid of this. So hopefully in future versions of Dagger, we should be all happier. So let's cover Jetpack a bit quickly, because I'm running out of time. So we've got the view model and other various things. So this is Jetpack was like the opinionated implementation of various types of things in Android, so that you can kind of hit the ground running, and you can sort of bootstrap development and get going quickly. Introduced in 2018, bootstrap Android development, optimized implementations, sort of breaking up the support library as well, and migrating to the Android X namespace. But more importantly, introduces the concept of view models. Now, view models are really interesting because they have this state persistence thing through configuration change. And now, if you're an Android developer, you probably are already familiar with the pain and hardship of configuration changes and how much this hurts. So having this kind of instance persisted through this is actually quite useful for us. So consider the view model fragment persistent method with scoping. What would this look like in a typical Dagger application? So your Android application is created, your activity is created, your Dagger component is then created, your view model is then created, and your fragment is then created because you have a headless fragment, or maybe you have your own fragments for whatever reason. And then a configuration change, everything dies. Well, no, your activity dies and your component dies. So if we want to persist anything, it has to go in either a fragment or on a view model. Now, this is quite cool, but we still have to manage our scope persistence here. You have to make sure as well that view model should never actually contain reference to any view class or anything with context. So we want to be able to utilize this and then get Dagger there. So if you've used the view model factories or have an injection paradigms here, you'll know that Dagger can be quite good with a multi-binding, but it's also a bit tricky to set up. So how should we kind of think about using Dagger to utilize building our view models? And how could this look like? Well, you do so carefully, unless you stab yourself in the face. So this is a naive kind of first try implementation, perhaps. It's also wrong. Since we have this inject constructor on the view model, and then we inject that directly into our activity. Now, what this will happen is it'll just create the view model every time, and it's sort of pointless because you're getting a new view model and you're not using the persistence that's provided from Jetpack. You're not getting this value of having a persistence through configuration change. But we want to still use Dagger with our injection and utilize our dependencies here and have these injected, but then have the same view model. So the problem here is that we're trying to inject the view model. Now, you just can't do it. You cannot simply inject a view model. It doesn't work yet. So we used to utilize Dagger multi-binding. And it might look like this. So you got the activity view model, which is an inject constructor, and then you have your Dagger view multi-binding setup. This is quite commonly used, and it's also probably the most copy-pasted code on Dagger and view models, because I think nobody knows actually how it works. It just works. So you define a module, you define your view model, you define this binding that you want to set up, then you define your view model key, you define your view model key specification, your name on the view model, you make sure this is having a model that is injected into the module, and then you have your module in the application graph, then you have a binding module for your activity. It's a bit much. And it's sort of implemented by using this sort of this view model factory. This is implementing the view model provider.factory because we all love those names from the Java Beans days. Let's add a few more on there: Java provider, factory, bean, factory, provider. But it's basically checking if there is an available view model provider in this map of injected view models. Now this is great, but we end up having a factory for everything in our class, everything in our application, every one of our view models. What if you wanted to kind of change this a little bit so that you just have one factory per view model, or it's a little bit more easier to set up something? You'd inject your factory and then actually use that via the providers instead. This is how you retrieve your view model. So You can also use the view model of KTX. I've got a lot of content here. I need to go through it. So there's a short link here on how to use this implementation, which is the multi-binding approach. Uses multi-binding build and map of providers, global factory to create all the view models, factory injected into activity and create view model, and it's a bit of a complicated initial setup. Because you need to set up this module for every view model, and then your application graph has all of the factories that you are using, so it's a bit kind of polluted. There's an alternative approach that I've seen being used quite often actually as well, is that where you define sort of your own factory. So you have a factory one-to-one thing with every view model. So for every view model, you have a factory. The problem here is that you're duplicating the method signatures. You've got all these kind of duplicate definitions here, and it's a bit, I mean, it respects single responsibility principle. It's nice and clean in its implementation, but it's duplicitous, and it's a bit boilerplate. And if we're working in Kotlin, we want to try and reduce this. So I've seen this one done as well. This was actually quite interesting, where you just inject the view model with the injected annotation. Now, the problem here is that the view model is going to get created every time you're trying to inject the factory. So you still have this view model being created every time, but it's not actually being used. You will get the right version, but you are creating an unnecessary object every time, which is only just going to get garbage collected. So it's not ideal. So how do we combine these two approaches and kind of get the best of both worlds? Well, the approach I've been trying to use recently is utilizing the provider of a view model injected into a view model factory. So you define this view model factory with a provider, and then you have this implementation just saying, is it the right class? Provider if it is, throw if it isn't. And then you don't have to have this kind of rubbish with all the modules and all these duplicate definitions for everything else. You can simply kind of define a factory on each one of your view models and then inject that one as you would normally. Still not like super ideal, but I've been told the Dagger team are working on improving this, so watch this space. But wait, there's more. Well, I might have to rush through this a little bit because I've only got 3 minutes left. But this concept of factories is really interesting, and it's being employed a lot more. And you might remember when I mentioned about having a constructor injection in Android framework types, such as activity and fragments. Well, this is where it's coming into play, because we're starting to get access to factories for Android components. And we have this app component factory, which is available in Android Pie, where you can then specify a non-noarg constructor for your activity. So you can have an activity with constructor injection, which is incredible, if all of your users are using Android Pie. We're in a bit of a better situation with the fragments because this is part of the Android X libraries, so you can actually start using this already. It's already stable, you can start using it. I think it's version 1.10. And we have this abstract state view model factory as well, which is the same as the normal view model factory, which is quite, as you're already familiar with. And finally, we have this layout inflator factory. There's a really interesting technique demonstrated by Jake Wharton about how to inject dependencies into your custom views. This has been a topic of hot debate because, should you inject logic into your views? Should your views have dependencies? Should your views be complex? It's a bit gray area. But if you really want to, if it really makes sense for your project, then you can do so using this layout inflator.factory technique. Using assisted inject, it's quite powerful actually. So you can have like a non-traditional constructor on your view. And the inflator might look like this. So, Kotlin experimental. Now, how do these new features kind of integrate with Dagger? So we have things like inline classes. Now, these are kind of quite cool. So wrapping primitive types so that you can benefit from the performance impact. So you no longer are hit by the performance impact. You have a single backing property, and you can apply extra functions and extra behavior onto this. And then it's represented by this inline class at runtime, which is cool. It's sometimes represented by a box type if it's necessary. This is a bit of a caveat, but let's not go into that now. Works out of the box, and it actually is interoperable with Dagger, but Dagger recognizes the inline class as its backing type. So if you have an inline class of a string, it'll just be a string, and then you'll have all the issues that you had with all the named annotations. You're not giving enough information about where it should be used, where the class should be used. And if it's a complex type, then you're not going to know if it's actually an inline class or a box class or if it's the actual original type, and if it's not qualified. Same applies to type alias. Type alias is just you telling a compiler, this is the same thing. You can't really use type aliases in Dagger. Maybe sometime in the future, but not currently. Binds. Method not required, just an instruction to Dagger to provide the type. It just tells Dagger that you need to, this is the type that's going to be returned. And it's not actually using your class here, it's just using it as a reference. You can use abstract classes to use the same, or you can use interface classes if you like having fewer words. Default implementations, denied. It doesn't work. Dagger, Kotlin will then kind of pass off to a integrated delegate implementation. Inline methods in Kotlin. Kotlin returns types that have been inferred from the body. You're probably familiar with this if you have methods return types, and then say if you're returning a string, and then you don't actually specify that the type is there, but your IDE will have this at the end as a kind of a hint. It's actually a bit tricky to use these things because you have this inferred type, and if that type then changes because you're calling an API, or if you're calling like a framework type, it could be nullable, or it could be something else, and it could change really easily. So I think it's a better practice to actually explicitly define your return types even when using it in Kotlin. And it helps your peers when they're reviewing it on GitHub. Default parameters, nope. JVM overloads, nope. But there's hope. We are starting to see more Dagger Kotlin support, as mentioned earlier. There's a proposal from Zach Swears on the Dagger project. There's the link at the end for this. And this is a proposal to introduce support for all these kind of type aliases and inline classes and all these different things that we can't currently use. There's also the talk from Emmanuel and Daniel at the Android Developer Summit. I really recommend watching this. There's a few kind of really nice introductions, nothing groundbreaking, but it's really kind of letting us know which way the project is going and how we can use this in the future. The most important thing to note is what is going on with Dagger.android. They are ceasing development on this. There have been no more features. It's not going to be developed further. But this doesn't mean that it's deprecated. There was the misunderstanding after the conference that this was deprecated. Not the case. They're just working on something else. Some further reading. Like I said, there's the talk from Manuel and Daniel at Google. There's the Google Code Lab on Dagger. Now, there's been some discussion recently on whether this is actually a good code lab, as it's quite complicated, but maybe we'll see this improve in the future. Some things on inline classes and autoboxing, when they're actually represented by inline classes or whether they're autoboxed. Helping Dagger help you. This was Jake Wharton's approach to inject dependencies into your custom views through use of assisted inject. And we have Dagger best practices, these ideas about using modules and how to use the annotations and things. And finally, Dagger official guidelines. And finally, Zach Swear's party tricks. This is going to be a series that Zach is sharing on Twitter. I really recommend following it because Zach's working directly on this code, and he's one of the most knowledgeable guys I've seen on it. And that makes everything. So thank you very much.
Ash Davies. Thank you very much, Ash. Do we have questions? Can I have Slido, please? Yes, 2 questions. Any work done for using Dagger or similar tool for Kotlin multi-platform? What do you recommend for this use case?
Ooh, I mean, these are different types of tools, really. I think I wouldn't think of using Dagger in JavaScript world as the different tools and different implementations. They're just too varied, and I think if Dagger were to try and cater for all these different things, then you're going to have this kind of multi-tool issue where jack of all trades, master of none type of thing. I wouldn't try and use Dagger outside of the JVM. So I can't really give any recommendations here, I'm afraid.
Thank you. And the second one, what is the main reason why Dagger is recommended by Google?
Probably because they wrote it. I mean, it's heavily recommended because Google uses it a lot internally for their own internal apps, and it scales really well. The setup might be a bit complicated, but once you've gotten over that hurdle, you can use it with really large applications quite well without much performance increase. Compare that to like a service locator or something else. I think the thing is that Google have always been quite unopinionated or sort of taken a back seat with these things and not really given any strong advice one way or the other. I have to remember Diane Hackborn's quote on Google Plus about architecture. Once your activity starts, we don't care what you do. But that's obviously changed since Jetpack, because Jetpack is providing these opinionated guidelines about where to start if you're a new developer, how to get going, and how to get going with these things. So I think Dagger is being recommended because it is probably the most robust solution available. It fits most of the scenarios, and they wrote it. So.
Okay, thank you. So again, Ash Davies, thank you very much.